Okay, so let's continue with optical communications. We will begin with what really this optical communication system looks like. So different from the other communication systems that we have discussed so far, this is a unique communication system because the carrier of our information dito is napakataas na frequency, no? Which is the light spectrum na. No? So optical communication system uses light as the carrier of information to be transmitted. So yun na yung napaka-unique na uri ng communication na to. No? And on the wavelengths of light, it only has 3 particular wavelengths na doon lang tayo gumagamit or doon lang natin pinapadala yung ating information. No? So the 3 carriers or what we term as the windows of fiber optics. No? So yung 850 nanometer, 1300 nanometer, and 1550 nanometer, that all belongs to the infrared spectrum. No? So alam natin sa ating introduction to electronics communications na meron tayong tatlong spectrum of light. So we have the infrared, we have the visible light, and we have the ultraviolet rays, no? Or ultraviolet na light. Then we have the 770 boundary na nanometer dito, and we have the 390 nanometer na boundary. No? So as you can see, the wavelength decreases because papunta doon the frequency increases. So lahat ng higher than 770 are wavelengths na under the infrared because those are frequencies below the red. No? So ito na yung rainbow na tinatawag natin, ROY, GB. No? So yun na yung colors na yan. No? So the red is 770. Frequency higher than the red, obviously visible mo niya before maging ultraviolet, but frequencies below the red, yun yung mga infrared with wavelengths longer than 770. And if you have noticed, 850, 1300, 1550, all of those wavelengths na yan are longer than 770, then we can really say na fiber optics communication doesn't use visible light nor the ultraviolet, but it uses the infrared na hindi rin nakikita na ating mga mata. So, tandaan natin yan. Okay? So, I have here the diagram for the pinaka-basic lang illustration of what is a optical communication. So, assuming we'll be transmitting analog signal. So, yung analog signal, hindi yan pwede ipapadala natin directly into the fiber. So, pwede naman, mayroon tayong analog transmission ng fiber, which is basically the intensity of light is being varied with respect to the magnitude of your modulating signal, but that is not the common communication na ginagamit sa fiber. No? So what really is used in a fiber is on-off lang. No? It's digital. So ibig sabihin, itong analog na to, maybe sa pamamagitan ng paggamit ng PCM, we could convert it into bits, and the bits will represent a high and low na voltage in which it could trigger the light source in order to turn on and off lang. So yun lang yung gagamitin natin, no? Turning on and off the light source in which the light could travel now inside your fiber as meron or walang light, in which it could be detected by the receiving end na pag may light, makakonvert yung light into current, and yung current na yun will develop a drop across a resistance halimbawa. So it can convert pag may current into high voltage, and pag walang kuryente into walang voltahe. So it could be like that. No? So from the light, nagiging pulse uli siya, in which pwede natin i-convert uli into analog by a digital to analog converter. So that could be the pinaka-whole system ng fiber optics. So ganun lang siya ka-simple kung titingnan natin, no? Kung overview, that's how it works. So why do you think that the telco ngayon is nagka-convert na ng mga microwave links nila into fiber optics na talaga, o di kaya the copper wires into fiber optics? So there must be maraming advantages nito, no? So actually yes, no? So sa panahon ngayon digital na tayo, no? So in digital communications, as we have discussed dati, no? Pinaka-disadvantage ng digital is the requirement of the bandwidth. Because nga, if you want to transmit in a higher data rate, it requires more and more bandwidth because nga in MR encoding pa lang, the bandwidth is equal to FB over N. So as you can see, if you wanna transmit more bitrate, it requires greater amount of bandwidth. So that is relationship talaga yan ni digital. So yung problema sa mga megahertz, kilohertz, and gigahertz is that mapupuno talaga yung capacity ng channel mo because nga hindi ganun kalawak yung bandwidth. But in light, the frequency there is so high. No? So the frequency is so high, the bandwidth there is sometimes sinasabi nga nila, no? That the bandwidth in optical communication is considered as infinite dahil parang hindi mo mauubos talaga. No? So yun na yung ibig sabihin niya, no? Wide bandwidth, advantage talaga yan. And compared to copper lines with the same length, halimbawa, 10 km copper at 10 km fiber, there could be malaki yung significant na kaibahan ng power na ma-receive dun sa end na yun. So that could lead to the conclusion that fiber optics has lesser loss compared to copper. At the same time, because these fiber optics are made not with conductors but with insulators lang, there would never be any Faraday's law dito. So in short, there could never be any interference or crosstalks because nga insulators won't cut magnetic flux and won't induce any EMF from those magnetic flux. So it's safe for any interference. Kahit magkakalapit-lapit pa yung mga fiber mo, wala talagang magiging interference dyan. No? And obviously safety for the reason na it doesn't carry any electrical signals. So it's safe to handle. Kumbaga, no? So disadvantages naman ng fiber, pinakauna is mas mahal siya kumpara sa copper. Lalo na if yung gagawin is transition from copper to fiber, so it's napakamahal, no? So it's replacing all the equipments and the lines. Mahal talaga, overhaul kumbaga. Then another one is yung pagiging fragile niya o brittle niya. So kailangan protektahan talaga siya because madali siyang masira, madali siyang mabasag, hindi siya ganoon ka-rugged as the copper. And it requires also expensive tools and instruments para i-test at saka i-splice yung mga fibers together with the expensive training din para sa mga tao na mag-handle nito. But all in all, nangingibaba pa rin yung advantages ng fiber. That's the reason why telco companies are investing now with a fiber compared sa disadvantages na nakikita. Because in the end, what the consumers want is the high data rate. So high data rate can only be provided with wide bandwidth, and fiber optics can provide it. So now let's move on to the fiber optic construction, yung kable mismo. So the fiber is made of silicon, not silicon but silica or glass and plastic. So it could be made of silica or glass. So another term for glass is silica, or maybe plastic material. And again, both of these materials are insulators. So they are insulators. Now, in constructing a fiber, there are two basic parts in which the light will be affected inside the fiber. No? Sila yung nakakapag deal with the light inside the fiber. So si core at saka si cladding lang. So sila lang dalawa. No? The other parts of the fiber, there could be so many layers in the fiber. No? But there are two basic parts in the fiber that affects how light behaves inside the fiber. And that is the core and the cladding. So the core is the central part. Ito yung core na tinatawag natin. So that's the core. So the core traps the light inside the fiber, so dapat hindi makawala, no? So it contains the light as it travels down the fiber, so hindi niya pinapakawalan yung light. And in order to do that, the core must have a higher refractive index kumpara sa cladding. So we already talked about the refractive index before, so we'll no longer discuss it now, no? So the refractive index of the core must be greater always than the cladding, and we will talk about that later, why. Then the cladding is the one that wraps the core. So clad is wrap, no? So it wraps the core so that the light will not escape also. So it wraps the core to ensure that the light will be trapped in the core. And this also protects the core from any nicks like mga maliliit na sugat and scratches. And also to give strength on the core. But that's not its priority talaga, no? Its priority na purpose is to serve as a wrapper dun sa core para hindi talaga makawala yung light, no? Then obviously the opposite here sa core, it has a refractive index lesser than the core. So in short, core mas dense, cladding mas lesser dense. Then we could also protect the fiber, no, with a jacket, but sometimes meron pa yung other layer dito, yung tinatawag natin na buffer. So before the jacket, meron pang buffer. Its job also is to protect din, no? So the jacket is the rubber one, no? So buffer could be another material na hindi pa rubber talaga, like the outside coating natin or the outside protection. Itong jacket, ito na talaga yung outside protection. So the rubber insulation to protect the core and cladding from being damaged, such as mga cuts na naman, nicks, and pagkabasag or crashing. Now, because these fibers are basically napaka-weak, no? Napaka-brittle, napaka-fragile, and we cannot bend it too much because bending it too much would break the fibers inside. Minsan meron niya mga wire na solid wires na matigas na nakakabit dito sa labas ng ating fiber to give extra support, just like this one, no? So yun yung tinatawag nating messenger wire. So the messenger wire is a wire that runs along with the fiber or maybe integrated lang. So minsan nakakabit lang yun by tying it. Tinatay lang siya. But minsan on the manufacturing side pa lang, kinakabitan na talaga ng messenger wire for strength, no? Mechanical support, kumbaga, no? Yun yung tinatawag na messenger wire. You can see this, no, sa mga fiber na ginagamit sa inyong mga mga fiber subscription ng internet sa bahay. So those are fibers na meron na mga messenger wire. Now, considering that we can only create a plastic and a glass na material for either the core and the cladding, so we could simply say that we could create 4 types of fibers, no? A plastic na core, plastic na cladding, glass na core, glass na cladding, or di kaya glass na core, plastic na cladding, or plastic na core, glass na cladding. So those would be the combination. But in reality, we only have 3. No? So hindi 4, 3 lang. No? Plastic core and cladding, or the PCP. No? Plastic core, plastic clads the plastic. So ibig sabihin, the plastic is the cladding, and the core also is plastic. So plastic clads the plastic. If the core is glass and the cladding is plastic, it means that plastic clads the silica. So yun yung PCS, plastic clads the silica, or the silica clads the silica. So yun yung ibig sabihin ng SCS. So wala tayong tinatawag na glass clads the plastic. So wala tayong silica clad plastic. So for the reason hindi siya po pwede because the glass has higher refractive index than the plastic. So the glass has higher refractive index than the plastic talaga. The silica has higher refractive index than the plastic, and we need to know and remember that the core should always be a higher refractive index than the cladding. So if we will say that the glass, the silica clads the plastic, then it violates this particular concept na, no? So kaya nga hindi po pwede yung silica clad plastic. Now we can only have plastic clad silica, or di ka plastic clad plastic, or silica clad silica, but never the silica clad plastic. So kung bakit, alamin natin. So this is now what we term as the principle na hindi makawala yung light inside the fiber, yung tinatawag nating total internal reflection. Now in total internal reflection, we need to make sure that our light will be trapped inside the fiber. So we will explain how it can happen. Now we know that N1 must be greater than N2. So assuming this is the critical angle, itong broken line na to is the critical angle ng ating fiber optic interface core to cladding. So if my halimbawa my ray is below the critical angle, ayan, it's lesser than the critical angle. So my ray of light is lesser than the critical angle. It hits this N1 greater than N2, so it will be refracted away from the normal. So we know that when N1 is greater than N2 in our wave propagation topic, optical properties, if we move from more to less, it moves away. So it will bend away dito. So it's not reflection yet. It's still refraction, but we want reflection to happen. So kaya nga pinakaunang kailangan nating makamit is that it must bend away from the normal. And for it to bend away from the normal, we need to make sure that your N1 is greater than N2. That's the reason why we cannot create a plastic na core and glass na cladding, because that would violate the N1 greater than N2. So it could become N2 greater than N1. That means it will refract and bend towards the normal. It will not have reflection at all. So for reflection to exist, we need to make sure that your N1 must be greater than N2 so that the refraction will be moving away from the normal. So the moment we hit an incident angle equivalent to the critical angle, our refraction there, assuming that N1 is greater than N2, our refraction there would be exactly 90 degrees. That's critical angle. And it still is not reflection. No? So in order for us to really reflect, we need to make sure that our incident angle now is greater than the critical. So ito na dapat yung ating incident angle. So the incident angle must be greater than the critical angle so that it will also refract beyond the 90 degrees. It means na bumalik tayo sa ating surface mismo, no? O sa ating material mismo. So at reflection, your incident angle is equal to your angle of reflection. So and pag-reflect natin dito sa kabilang end ng ating fiber core cladding interface, we are again greater than the critical. So it will again reflect and it will follow this hanggang sa dulo ng ating fiber optic line. So that is now trapping the fiber, or trapping the light rather, inside the core. No? So that's the reason why your N1 should be greater than N2 para it will bend away from the normal. And in order for it to really reflect na, you need to make sure that your incident angle is greater than your critical angle. So ito yung mga grounds para magkaroon tayo ng total internal reflection. No? So N1 must be greater than N2 to refract away and away and away. And for it to reflect na, your incident must be greater than the critical. Okay, so let's move on to the light gathering naman ng inyong fiber. So kanina, a while ago lang, we are talking about how the light behaves inside the fiber. So now ngayon, we will be talking about how the light behaves outside the fiber towards inside the fiber. So let's begin with this fiber optic cable. Now this is the interface from air. So ito yung air natin, ito yung fiber optic cable natin. So this is what we term as the interface of air to fiber. But this is the interface naman na tinatawag na core to cladding. So yun yung kaibahan, no? Air to fiber interface nandito, core to cladding interface nandyan. So this is the central axis of the fiber, ito yung nasa gitna ng axis ng fiber. And assuming that we have a ray right here, our incident angle will always be from the normal in the central axis. Why? Because our interface is nandito. So our interface is here, so perpendicular to our interface would be the normal. So ito yung normal line natin. So this one I will label as the normal line for this air to fiber. So from air to fiber, assuming we have an incident angle here, so we know that the N of air is lesser than the N of your core. So we are now moving from less to more. So if it is less to more, then it will be moving towards the normal. So it will be bend. It will bend towards the normal. Without bending, that would be the direction of your ray. But because now we are moving from air to fiber, we have N1, N of the air is lesser than the N of the fiber, then it would bend towards the normal just like this. No? So it bends towards the normal. So ito yung normal line natin, towards the normal. Now, when it hits the core cladding interface, makikita natin if this is the normal line of the core cladding interface and this is the critical angle, it's beyond the critical angle. So obviously it will reflect. Expanding this angle here at the air to fiber interface without any refraction, it would go straight. But because we are from air to fiber interface, we are from air to the fiber, it is from less to more, it will again move towards the normal. So it moves towards the normal na naman. So considering the same critical angle at the core to cladding interface, it still is greater than the critical angle. So it means na it will still reflect. Now let's have another ray that is greater than the incident of the second one. No? So this is the first incident angle, the second incident angle, and this is the third incident angle. So without bending, it would go straight there, but with bending, it will move towards the normal. So it is bended towards the normal. Now considering the same critical angle, it is now less than the critical angle. So if you are moving from more to less, but you are less than the critical, you will bend lang, but will never reflect. So ibig sabihin, it will only bend to the cladding, and it cannot reflect into the core and proceed towards the end of the fiber. So ibig sabihin, meron palang limitation yung aking angle dito sa air to fiber interface, na beyond that particular angle, our light could no longer be trapped inside the core, but instead it will now travel in the cladding. It will be refracted in the cladding. So, and this is the angle na yan. Ito yung angle na yan. No? Because beyond that, as we know, it already escapes into the cladding. So there is a maximum angle of incident dito sa labas, no? That will limit the flow of your light inside the core, na beyond that, it will now go to the cladding. So ano yung tawag natin dito? So yun na yung tinatawag na light gathering ability ng ating fiber, ganong kalaki yung angle na yan. So that basically is what we term as the angle of acceptance, in which pag paikutin natin yan, it becomes the acceptance cone angle. So ibig sabihin, from here to here is the acceptance cone angle, ang kalahatin yan is the acceptance angle lang. No? So acceptance angle is half the acceptance cone angle. So kaya nga, pag tinatawag yung acceptance angle as the acceptance cone half angle. So yun yung kaibahan ng dalawa. No? So acceptance angle or the acceptance cone half angle is the maximum angle in which the external, yung galing sa labas, no, ray may strike the air to fiber interface and still propagate on the fiber. And it's clearly illustrated here that as we go beyond the angle of acceptance or the acceptance angle, our light ray refracts in the cladding. No? So hopefully naintindihan natin yung significance ng acceptance angle. It's like a funnel. It's like sa Bisaya pa, embudo, no? For the light to travel inside the fiber. Beyond that embudo, beyond that funnel, it spills out and hindi na makapasok sa fiber natin. So yun yung light gathering ability niya. But meron ito equivalent na number. Yung tawag sa equivalent number ito is the numerical aperture na sikat na sikat. No? But before proceeding, let's have the formula for the acceptance angle. So acceptance angle can be solved using the formula arc sine of n1 squared, the refractive index of your core, and minus the refractive index of your cladding. So that would be the acceptance angle square root. And this value here is actually the numerical aperture. Yun talaga yung numerical aperture, or the arc sine of the numerical aperture becomes the acceptance angle. So yun yung pinaka makikita natin dito, no? So numerical aperture is described as the light gathering ability of the optical fiber, which is more na ginagamit kumpara sa acceptance angle, because nga the higher this number, the higher is your ability to gather light. The lower this number, the lower is the ability to gather light. Wala ka nang i-analyze pa, diretso mo na lang ma-interpret if nandun ka sa field, no? So the numerical aperture basically is n1 squared minus n2 squared, or that is also the sine of your acceptance angle. No? So the sine of your acceptance angle is your numerical aperture. The arc sine of your numerical aperture is the acceptance angle. So they're pretty much related lang talaga. Okay, so now let's move on to the types of rays that could flow into your fiber. So one is the meridional ray. So meridional ray is pinaka-basics ating mga example. So it is the type of ray that passes always the central axis of the fiber. So as you can see, as it reflects inside the core of our fiber, it always passes through this central axis. So lateral na view natin, it will only reflect from core cladding interface like this, up, down, always passing at the center. But that is not how the skew ray behaves. The skew ray doesn't pass through the central axis of the fiber. So the ray does not pass through the center. It takes somewhat similar shape of a spiral or helical path, just like this. No? So the skew rays reflect off from the core cladding boundaries and again bounces around this outside of the core, as we can see here. No? So if this is our central axis, even though our rays will be reflected from core cladding interface to core cladding interface, but it will not pass to the center, just like this one. No? Pumunta siya dyan, then nang tumama sa boundary, nag-reflect siya to another boundary, nag-reflect to another boundary, nag-reflect to another boundary, and hindi siya talaga dumaan sa gitna ng ating fiber. So that's what you term as the skew ray. No? So in the side view na, so it could be like this. No? Ayan. So para siyang paikot, no? Paikot yung daloy ng ating light sa loob ng fiber. So that is now referred as the skew ray. So meridional ray, yun yung typical. Skew ray, yun yung paikot. Okay, let's move on now to the modes of the fiber, in which pretty much related to the modes of your waveguides. So modes will always be the number of ways or paths in which the light travels inside a fiber, or electromagnetic waves travel inside a waveguide. So pareho lang naman yan. No? So kaya nga we could also say na may single mode dito and may multimode. So single mode, isang daan lang yung ginagamit ng light sa loob ng fiber. So that's how it moves inside the fiber. Pag sinabi mong multimode, it means na there could be more reflections na path or there could be less reflections na path. No? So that would be multimodal. Now, there can also be referred as the profile or index profile or the refractive index profile para hindi ka malilito nito. No? So, refractive index profile. In short, it's profiling your refractive index. So, ibig sabihin, tinitingnan mo kung ano yung relationship or behavior ng refractive index mo in your fiber. No? So it refers to the graphical representation of the value of the refractive index across the fiber. So there are also two. No? So we have the step index, in which there is an abrupt change of the refractive index from the core to cladding. So it means na si core may ibang refractive index, si cladding may ibang refractive index. But kahit saan ka sa core, pareho lang yung refractive index. Kahit saan ka sa cladding, pareho lang din yung refractive index niya provided by this graph. So as you can see, the same color lang lahat ng parts ng cladding, the same color lang din ng parts ng core, representing the value of the refractive index na pareho lang talaga within the core and pareho lang within the cladding. But the darker shade here tells us na mas mataas yung refractive index ng core kumpara sa cladding. So graphically, representing it, there is an abrupt change. No? Merong sariling refractive index si core, may sariling refractive index si cladding, and there is no change within the core and there is no change within the cladding lang. No? That is different from the gradient because from the word gradient, it means gradual, gradient. So dahan-dahan yung pagbabago, and that is what is happening in a graded index. Yung coarse refractive index mo is may dahan-dahang pagbabago. The darkest shade means that is the highest refractive index, and that is and as it goes outwards the core, dahan-dahang lumiliit yung refractive index, providing you a graded index. So the coarse refractive index gradually decreases with increasing radial distance. So from the center of the core, as you move with greater distance palabas, lumiliit yung refractive index ng core mo. So by having a graph, it could be seen na hindi siya actual step, no? But merong pagbabago, no? Gradual na pagbabago. Pinakamataas na yun yung highest refractive index. Lowest refractive naman doon sa boundary o pinaka-outside ng ating core. So yun naman yun. So kaya kung considering these modes na dalawa, an index profile na dalawa, we can actually configure 4 types of fibers. No? Makakagawa tayo ng 4 na uri ng fiber. No? So we could have single mode step index, single mode graded index, multi-mode step index, and multi-mode graded index. But in reality, practically speaking, there are only 3 So ano kaya yung hindi na ginagawa dito, no? Yung hindi ginagamit practically. So yan yung pag-uusapan natin dito sa fiber configurations. So let's begin with the pinaka-common sa lahat, the multimode step index. So multimode step index common types are the 5125 or the 62.5125. So ano ba yung ibig sabihin ng 5125? Or ano ba yung ibig sabihin ng coding na ganito? No? So it's actually pretty simple. Yung first number dito is the diameter of the core in microns or micrometers, and the second is the diameter of the cladding in microns. So ibig sabihin, pag sinabi mong 50/125, then the core is 50 micrometer, the cladding is 125 micrometer. So that would be medyo malaki yung kanyang core kumpara mamaya sa single mode step index. No? Why? Because it's designed for multimode. So in multimode step index, there is a step index to profile, and there will be 2 ways or more ways for the signal light to travel into the fiber. That could somehow becomes a problem because of the different paths that would provide us with different arrival times that could basically lead to the problem na naman of what we have experienced in the waveguides, no? Yung tinatawag na dispersion. So, advantage nga lang ng multimode step index is that malaki yung kanyang diameter, no? Yung core diameter niya is malaki. Ayan, 50 to 100, 1,000 microns core diameter, and because of that malaki na diameter, mabilis siyang makapagpapasok ng light kasi nga hindi mahihirapan kasi malaki na yung core diameter niya. Then, because of that, hindi siya ganun kahirap gawin, pinakamadaling gawin na fiber. So pag pinakamadali kang gawin, hindi yan mataas na presyo, no? So ibig sabihin mura yan, and because of that, pinaka-commonly used siya na fiber. So yun nagdo-domino effect na yung advantages lang dahil sa malaki yung kanyang core. So parang isipin natin na pag malaki yung core ng isang fiber diameter, madali lang siyang gawin. And because madali siyang gawin, hindi siya mahal. And because hindi siya mahal, then it is commonly na mabibili. Ayan. So yun yung parang practical way to think why the multimode step index is pinaka-common na uri ng fiber. But if you will say, is it the best? Hindi naman. So hindi siya talaga pinaka-best because nga it could lead to what we term as dispersion na we'll discuss maya-maya. No? So to solve for the number of modes ng fiber, we can use this formula, pi times the diameter of the core times the numerical aperture, in which we can solve n1 squared minus n2 squared square root divided by the wavelength will be provided na. No? So yung wavelength mo diretso dito ipoprovide na, hindi ka na mag-solve ng 3 exponent 8 divided by the frequency. Automatic na yung wavelength ipoprovide. Basta tandaan lang natin na yung mga diameter natin naka-microns, yung mga wavelength natin naka-nanometer, we just need to be consistent. No? So just make it into meters lang lahat, like -6 meter at saka -9 meter para consistent yung unit natin, and that provides us with a number of modes. So now let's look at the disadvantage of multimode. So disadvantage of multimode comes also with the large diameter niya. No? So because large diameter siya, maraming dumadaan na path of light, and because of that, it could lead to what we term as dispersion. So dispersion is the stretching. We have already discussed this in waveguides. No? The pulse due to the different arrival times. No? We have discussed it already. So if I have a pulse and it takes 2 paths lang halimbawa, na unang dumating yung pulse, but because there is another pulse pa with more reflections, so mas nahuli siyang dumating, kaya nga in the end part nito may sumunod na pulse na in which yung ating gusto na pulse width is ito lang, but on the recovered end mas stretch na yung pulse natin. That could lead to a misrepresentation of the digital signal that we have transmitted. So yun yung problema ngayon ng multimode step. But accepted mo yan na pag multimode step ka, meron talagang dispersion. So yun yung drawback talaga niya. No? So if the dispersion is due to the multimodal operation natin, dahil nga nag-multimode tayo, then that would be referred as the modal dispersion specifically. No? So due to the multimodal. But there is also a dispersion that is not really due to the multimodal that could happen in a single mode step index. Yung tinatawag na chromatic dispersion. So chromatic dispersion is not really due to the multimodal but because lang of different wavelengths dito sa ating waveguide. So hindi natin siya inoperate talaga na multimode, but because with different wavelengths during WDM. So what is WDM? That is wavelength division multiplexing. So this is letter M. So wavelength division multiplexing, WDM. Pag may D pa, dense wavelength division multiplexing, we'll discuss that later. Because of this, there would be so many wavelengths dito that could somehow travel at different speed. So kahit ipagpalagay natin na isa lang yung path nila, but because different wavelengths travel at different speed, then it could somehow lead to may nauuna and may nahuhuli, and there could still be stretching of the pulse. So that is now referred as the chromatic dispersion. So chromatic dispersion is not really because inallow mo na magkaroon ng multimode operation, but nang dahil lang sa maraming wavelengths yung dumadaan dun sa ating fiber. Kaya may mauuna, may mahuhuli talaga na wavelength. That could lead again to another dispersion. Okay, so now let's continue with the single mode step index. So papapansin natin dito na malaki talaga yung kaibahan ng kanilang core at saka ng cladding. No? So kanina sa multimode, it's 50 and 62.5. Ngayon, it's 9 and 8.3. That could be napakalaking kaibahan. So that is to make sure na isa lang talaga yung light path doon sa ating fiber. No? Monomode, single mode. So that basically is the same. So ito na yung kaibahan, no? Kanina malaki yung diameter ng core, dito maliit na yung diameter ng core para mapilitan yung ating path of light na isa lang talaga siya dun sa loob ng ating fiber. So this is now the formula to solve for the core radius, 0.383 lambda over numerical aperture, and we can also solve for the cutoff wavelength equivalent to pi dNA over 2.405. That would be the cutoff wavelength. So be familiar with these equations here. No? Yung mnemonic nito is 0.383 lambda na. And this one is paid na para maglambada by how much? 2.405. So we could actually rewrite it to 2.405 equal to paid na para maglambada. How much is yung binayad para maglambada? It's 2.405. That's somehow the mnemonic here. No? Okay, so advantages ng single mode, maliit yung kanyang core diameter. No? So pag maliit yung kanyang core diameter, ibig sabihin, napipilitan yung ating light to travel in a almost a straight path, lesser reflections at all, no? And with that, it eliminates the modal dispersion because nga isa lang yung path ng ating signal. But there could still be dispersion here. Hindi nga lang modal, but yung chromatic dispersion. No? Maximum data rate because of the almost straight path, less reflections, and it is now considered as the best type. So the most common type is the multimode step, but the best type is the single mode step. Yun na yung best type. Disadvantage is obviously mahal. Kasi nga, maliit na maliit yung core diameter, mahirap gawin, then it comes with a price. So yun na yun. No? Difficulty to make, very expensive, and difficult to splice because of napakaliit na core diameter. Okay, let's move on to multimode naman na graded. Ito shortcut. No? If you want the shortcut for multimode, isipin mo lang, it's midway. So, nasa gitna siya ni single mode step and multimode graded. But because it's multimode, it also still has mas malaki pa rin na core diameter kumpara sa step index. Actually, pareho lang yung kanyang typical type or common types doon sa ating multimode na step. No? 50, 125, 62.5, 125 pa rin. So, to determine how the light behaves inside the multimode graded, let's have an idea. No? If a ray is projected in this direction inside a graded fiber, wala kasing exact point of reflection dito for the reason na nagbabago kasi yung refractive index mo from the center going outside the core. So kaya nga we can only assume na lang na if you are moving papunta doon, we are moving from more to less, in which that we could bend away. And as we get the interface here, imagine an interface, it would still bend away because we are still moving more to less, bending away. But what if at this point here, you are already beyond the critical angle? Then at that point, you will now begin to reflect. And now you are moving more to less, less to more rather, no? Less to more. From outer is lesser to inner is more. Less to more that you will bend towards the normal. And here you bend towards the normal. So that is how the light behaves inside your graded. It's not like a straight then point of reflection, reflect, a straight point of reflection, reflect. Hindi ganun. No? Gradual kasi yung pagbabago ng refractive index natin. So ibig sabihin from the center of the fiber, dahan-dahan kang magbibend until pagdating sa dulo na to, you have a higher refractive, you have a higher incident na with your critical angle, then you begin to bend pababa. Kumbaga nag-reflect ka na. And it will go like that. No? So yun yung behavior ng light mo inside the graded fiber. So kaya kung makakita ka ng fiber na yung behavior ng light is parang sine wave sa loob, it's a graded fiber. But obviously, that should be multimode. So marami yung mga daan na yan papunta sa ating destination. So multi-mode graded yan. Okay, so multi-mode graded is a compromise, no? Nasa gitna siya, kalagitnaan ng single mode step and multi-mode step, no? So the core size is 50 to 100, as you can see, 52.5, and the advantages is depending kung saan natin i-compare, no? So comparing it to the multi-mode step index, like multi-mode step index, it has less dispersion and it has a faster data rate than the multi-mode step index. But compared to the single mode step index, it is easier to splice because of its wider diameter. So mga it's just basically in between lang ni multi-mode step at saka ni single mode step. So the reason why the multi-mode graded is the only graded with respect to the configurations, but wala tayong single mode graded, for the reason na yung single mode graded na nandun na sa 8 microns yung core diameter is mahirap nang gawin. Step index pa yun. Can you imagine if ganun kaliit na diameter tapos i-graded pa natin, like i-gradual pa yung refractive index. So that could be napakahirap. Mas mahirap pang gawin. Mas magiging mahal pa to. In which it's no longer practical. Why? Kayang-kaya na nga ni single mode step index yung pinaka-best na transmission. Why would you create something na mas mahal na hindi din naman ganun kalaki yung magiging improvement? So kaya practically speaking, wala talagang single mode na graded index. So that's the reason why we only have 3. Single mode step, multi-mode step, and multi-mode graded. So walang single mode na graded. Okay, so now let's move on to the optical transmitter and the receiver of our fiber optic system.